All right, welcome everyone. If you're an automotive engineer, this briefing is for you. We're going to cut right to the chase and lay out the strategic powertrain outlook for the critical 2024 to 2026 window. So let's jump right in.
Okay, so let's get one thing straight right off the bat. For the last decade, everything's been about this simple choice, ICE versus BEV. Well, I'm here to tell you that narrative is officially over. We are now heading into a much, much more complex reality, one with multiple pathways, all driven by some massive shifts in regulations and, of course, the market itself. So here's how we're going to break this down. We'll start high level with the new paradigm. Then we'll drill into the regulations that are changing the game. After that, we'll look at what's happening with both ICE and EV tech, and we'll wrap up with a playbook, some really concrete, actionable steps for you and your teams. All right, section 1. So what is this new paradigm? Well, we're calling this period stagflation. And what does that mean? It's this really unique kind of tough situation where global production growth has flattened out, it's stagnant, but at the same time, the technology is transforming at a breakneck pace, and that transformation is expensive. So the most crucial concept to grasp right now is this idea of technology neutrality. The bottom line? Regulators are starting to shift away from just pushing for electrification at all costs. Instead, they're setting the emissions targets and basically saying, you hit these numbers, we don't care how you do it. And that, right there, opens the door wide open for real innovation across every type of powertrain. So what's driving this whole recalibration? Well, it really boils down to one primary force. The regulatory landscape is going through a massive evolution. I mean, the very definition of what we call a clean vehicle is fundamentally changing right before our eyes. Okay, take a look at these dates. Seriously, these need to be circled in red on every project manager's calendar. The timeline for Euro 7 is, well, it's aggressive. We're talking late 2026 for new light-duty vehicle types. Heavy-duty isn't far behind. That is not a lot of runway, folks. The pressure is on. And when we talk about Euro 7, it's so much more than just tighter numbers on the old rules. The big deal here is the massive expansion of scope. We're talking about entirely new frontiers. For the very first time, regulators are looking beyond the tailpipe. They're going after brake dust, tire particulates, and they're even adding new compounds we have to worry about, like nitrous oxide and ammonia. And let's just focus on this for a second. 3 milligrams per kilometer. This single number. This is forcing a complete reinvention of something we've been doing for 100 years. Friction brakes. The entire design philosophy is being challenged. It's kicking off a huge engineering effort into new coatings, smarter regen strategies, even things like active filtration systems for brakes. It's a whole new world. Okay, so besides non-exhaust emissions, here's the other massive regulatory shift, the move to a full life cycle assessment, or LCA. It's this whole cradle-to-grave thinking. The conversation is no longer just about what comes out of the tailpipe. Not at all. Now we have to account for everything, the carbon debt from building the car, especially the battery, and the carbon footprint of the fuel or the electricity you put into it. So, keeping that whole cradle-to-grave idea in our heads, let's switch gears and talk about the internal combustion engine. Because, believe it or not, it's staging a pretty surprising comeback. And it's all thanks to a new generation of fuels. Look, we have to be clear, this is not your grandpa's engine. We're not even talking about the engine from 5 years ago. Modern ICE development is chasing an incredible 50% brake thermal efficiency. We're seeing tech like turbulent jet ignition literally jump from Formula One cars into production vehicles. And when you add hardware like electrically heated CATs and dual SCR systems, the ones that use urea for NOx, you are getting to near zero pollutant emissions in the real world. This is a game changer. Now, this is the slide that puts it all together. This is the payoff for all that LCA talk. Just look at the 2 bars on the far right. What you're seeing is that an advanced ICE vehicle running on a carbon-neutral e-fuel has a total life cycle carbon footprint that is basically the same as a BEV that's charged with 100% pure wind power. Let that sink in. This completely reframes the entire debate. So this quote really hits the nail on the head. All that data is pointing to a massive shift in how we think about the problem. The real engineering challenge is being redefined. It's not about killing the engine anymore. It's about decarbonizing the fuel that goes into it. Okay, so that's the ICE story. But at the same time, there's a parallel race happening in the BEV space. And it's a different kind of race. While ICE is all about the fuel, the EV world is locked in this absolutely brutal battle for cost reduction through what we're calling hyper-integration. And at the same time, it's a strategic fight to secure and de-risk the supply chain. The engineering challenge for EVs has totally evolved. It's not just about making it work anymore. The real driver now is extreme cost pressure. And that's pushing this trend toward radical integration. We've gone from 3-in-1 systems to seeing these 8-in-1 e-axles that cram everything: the motor, inverter, gearbox, VCU, BMS, power distribution, you name it, into one single compact and, most importantly, cost-optimized unit. And this table really breaks down the strategic choices that e-powertrain engineers are grappling with. Everyone knows permanent magnet motors are the gold standard for efficiency, right? But the problem is their heavy reliance on rare earth metals, which is a huge geopolitical headache. And that's exactly why you're seeing this big push, especially in Europe, toward externally excited synchronous motors, or EESM. You get really high efficiency, but without that massive supply chain risk.
Okay, so we've covered a lot of ground. The big picture, regulations, tech trends. So what? What does this actually mean for you and your team on a Monday morning? Let's boil all this down into a direct, actionable engineering playbook for the next 2 years. First things first, you have to get serious about active thermal management. Passive heat management is just not gonna cut it anymore. Especially if you're in heavy-duty or non-road applications trying to pass these new low-load cycle tests. A powerful 5-kilowatt electrically heated catalyst, an EHC, isn't a nice-to-have. It is absolutely essential for compliance. Full stop. Step 2, life cycle assessment has to be baked into your design process from day one, from the absolute beginning. Your powertrain trade-off studies can't just be about tailpipe emissions anymore. You have to be modeling the carbon debt from manufacturing the battery and the real-world emissions from the entire fuel and electricity supply chain. Number 3 is about architecture. You have to start thinking modularly. If you design a flexible aftertreatment system, one with, say, a close-coupled plus underfloor layout, it gives you a platform. You can then add or remove components like a second SCR catalyst to meet different global standards like Euro 7 or Tier 5, all without having to do a complete, costly redesign. We're talking about saving millions in development here. And finally, step 4, get ready for digital compliance. The new onboard monitoring rules, OBM, are a data game. Your vehicle's entire communication architecture has to be built to handle and securely transmit real-time emissions data. And let's be honest, this is as much a cybersecurity and IT challenge as it is a traditional powertrain problem. So, all of this brings us to one final, really important strategic question for you to take back to your teams. The days of being just an engine guy or an EV person, those days are over. This great recalibration that's happening demands deep expertise across the board in advanced combustion, in high-voltage electronics, and in really complex software controls. So the real question is your team truly broad enough to compete?